Hi, my name is Phil Bagg and we're going to explore conditions that start actions in this video. You can find more essential knowledge videos at codeit.co.uk/video. You are looking at a semantic wave, which is great for thinking about curriculum sequencing. The idea is to take a complex idea such as conditional selection and unpack the concept until we get to the most concrete examples and simplest meanings. Starting at the red arrow, you can see us doing that on the downward curve from left to right. What is a condition and everyday examples of conditional selection? At the bottom we have pupils acting out concrete examples. Then the curve to the right is when we repack meaning to get back to more complex understanding. Flow of control, concept in code, limited number of conditions in code. In the rest of the video we're going to unpick this even more. If you have covered conditions that end loops previously, now is a great time to refresh people's memory, helping them to retrieve prior knowledge. If you haven't covered this type of repetition, ignore this slide. Before we use a condition, we need to describe what a simple algorithmic condition is. Basically, it's any question that can be answered with either yes or no, or true or false. It can help to check pupils' understanding of a simple condition with a simple question like this. We can identify that C is not a good condition because we can't get to a yes or no or true or false answer from it. It helps to identify the condition and the action in the algorithm. Pupils will have lots of experience of everyday conditions that start actions. When adults say these type of things, they are making the actions, in this case, Game Boy access or a treat, dependent on meeting the condition. Recalling everyday conditions that start actions will help pupils to relate conditions that start actions to a pre-existing knowledge they already have. It helps to identify what is affected by the condition and what is not affected by the condition. Algorithms can be written in any way another human can understand, so other methods other than indentations can be used, but indentation works well, as many programming languages indent code affected by conditions, including, if you look carefully, Scratch. Getting pupils to act out everyday algorithms with a partner helps to make the learning more active and gives the teacher something to observe, to see if pupils are carrying out correctly. Working with algorithms that include actions affected by the condition and those that are not affected by the condition gives teachers a chance to see if pupils understand the parts of the algorithm in a simple context. A common misconception is that a condition is checked over and over again rather than only following the flow of control and only being checked once, unless of course it's in a loop. When pupils write their own condition starts actions in algorithm, it gives us a chance to check if they understand the concept in one of its simplest forms, away from the complexities of code. When pupils write their own conditions, we are also helping to build up a possible way pupils can plan programming. Jane Waite, in her research in the UK, identified programming planning as an area of neglect. The national curriculum talks about designing and programming. Modelling good practice helps. Here we have used a decision diamond to represent our condition. We can then demonstrate how this works by talking through the actions or tracing the flow of control on the diagram. Going down the orange path if the condition was true and down the blue path if it was false. It can really help to trace that and point it out as you're acting out some of these algorithms. Getting pupils to draw the flow of control helps teachers to check if pupils understand this algorithmic order. Once we have established the basics, we can then move on to look at the concept in whatever programming language we have chosen. Here is Scratch code. It also identifies conditions with an if. If you look carefully, code affected by the condition is indented. The flow of control helps to show pupils the two pathways and helps them develop a mental picture of what the code does within the machine. It also helps pupils to see the link between that everyday algorithm we had a look at briefly earlier and code. The condition will only be checked if we are touching red when this condition is checked. If it was touching red during the count controlled loop at the start of this, all the way through, but then stopped touching red on the 9th loop, it would not be true. Earlier we talked about conditions being questions we could answer yes or no, true or false to. Here we are further refining the concept. when it works on a digital device, explaining to pupils that Scratch, or any programming language really, has a limited number of possible conditions to choose from, unlike conditions in algorithmic form. Let us summarise what we've learned. A condition is a state we can check to see if it is true or false. Conditions start with an if. Conditions are only checked once unless they're in a loop. After a condition is checked, there are two possible pathways, true or false. Conditions are only checked when reached in the flow of control. My thanks to the Everyday Computing team who have published a great repetition and selection trajectory that I have learned from. Do go and look at their research. My thanks also to the others mentioned here for their research and support. As always, all misconceptions and errors are my own. Do get in touch if you have any questions. In Highest, Hampshire inspectors provide resources on every area of the curriculum that you can find on our Moodle. You're welcome to subscribe if you're inside or outside of Hampshire.